Welcome to my YouTube channel Abhijit classes. In today's video we are going to discuss a problem based on rotational dynamics. This problem is based on the conservation of angular momentum. So friends, let us start. A disk is hinged at the center. The mass of the disk is capital M and the radius is r. A small particle of mass small m strikes the edge with a velocity v in a tangential direction of the disk and gets embedded in it. Calculate the final angular velocity of the disk. So friends, this is the initial situation and this is the final situation. So we have a particle of mass small m which strikes the edge of the disk with a velocity v in a tangential direction of the disk and gets embedded in it. Calculate the final angular velocity of the disk. So I am going to play the animation. This will help you in visualizing this problem. I am going to repeat the animation. As you can see, a particle of mass m strikes the edge of the disk with a velocity v in the tangential direction and get embedded in it. So finally this disk starts to rotate with an angular velocity. We need to figure out the final angular velocity of the disk. Okay, so assuming that this is the initial situation and this is the final situation. The disk is hinged at the center. Suppose the center is at O. Now the mass of the disk is capital M and the mass of the particle is small m. Assuming that the angular velocity of the disk is omega, and we are going to find this omega. Now how to solve this question? You can see that the only external force on the system is the reaction at the hinge, which is acting at the center. Now the net external torque or the angular impulse about the hinge or about point O is 0. Therefore we can apply the principle of conservation of angular momentum about the hinge point or about the point O, which is the center of the disk. So applying principle of conservation of angular momentum about the point O, which is hinge point, we can write the initial angular momentum is equals to final angular momentum. Now the initial angular momentum of particle, angular momentum of particle is initially the particle striking the disk with a velocity v, and we are going to conserve the angular momentum about point O. So guys, you can see that the initial this distance is equals to the r, the length of the lever arm is equal to r. So initial angular momentum of the particle is mvr. Initial angular momentum of the disk is, initially the disk is at rest, so it is 0. What about the final angular momentum? Final angular momentum of particle is m. The particle is embedded in the disk and it is rotating with the angular velocity omega. The moment of inertia of the particle about point O is mr square multiplied by omega. The moment of inertia of the particle is mr square about the center O. This is the distance r. So mr square omega. Final angular momentum of disk is ICM into omega, which is mr square over 2 multiplied by omega. Now applying the conservation of angular momentum, so we can write that initial angular momentum is equals to final angular momentum. So initial angular momentum is mvr of the particle. The angular momentum of the disk is 0 initially. The final angular momentum of the disk is the particle is mr square omega. The final angular momentum of the particle is mr square upon 2 omega. So we can write this implies omega is equals to mvr upon m plus m over 2 into r square. Therefore omega is equals to v over r multiplied by 2m upon m plus 2m. So guys, this is the answer. This is the final angular velocity with which the disk is rotating. So friends, you can subscribe to my channel to get more videos related to physics, and do press the bell icon to get every notification related to my physics videos. Thank you for watching.